Hello Precalculus student, this video is for chapter 5.4, Right Triangle Trigonometry. We're going to look at another definition of sine, cosine, and tangent function where the angle input, t or theta, is between 0 degree and 90 degree. Namely, we are concentrating on the input being in the first quadrant in the O unit circle definition. Remember, in the O unit circle definition, we would draw a unit circle. And then whatever angle that we have, if it is in the first quadrant, we would look at this point of intersection xy, and we define y is equal to sine t and x is equal to cosine t. So that is the basic definition of sine and cosine. And t, if t is in this quadrant, you can see that we can draw a triangle here. I think I mentioned that before. And you will see that this length is actually y, and the horizontal length is actually x. And if you move this triangle out to blow it up a little bit, you can see that this is angle t or theta if we want to, and it will be y and 1. This is 1 because it's a unit circle, and this is x. So we can say that actually sine theta is y, is actually y over 1, or if we look at this as a right triangle, is the opposite of t. We call it the opposite side over the hypotenuse in a right triangle. And whereas cosine t is x over 1 is called the adjacent side of this right triangle over hypotenuse. And if that is the case, we can actually define three function which is not periodical, is just primarily how we can actually relate the sides of a right triangle with sine and cosine and tangent. Namely, sine would be opposite over hypotenuse. We call it O over H. Okay, cosine would be adjacent over H. And then tangent would be opposite of adjacent. And it is valid for any triangle, not just the triangle that you draw on the unit circle restricted by xy. It is because if you extend this out, you would have similar triangle, and in geometry you would know that in similar triangle, ratio of the sides, corresponding sides are the same. So meaning this ratio of sine t, cosine t, and tangent t would still be the same for any opposite over hypotenuse side for sine, cosine, and tangent. And we can actually memorize this kind of ratio as SOHCAHTOA. SOHCAHTOA, SOHCAHTOA. Okay, O over H, A over H, TOA, T, tangent is O over A. SOHCAHTOA is very popular. In YouTube, you Google, or if you go to YouTube and say SOHCAHTOA songs, there are tons of them. And if you hear a few, you will remember SOHCAHTOA. You'll remember how to relate sides of a triangle with these angles. Now, I want to give a warning. So this angle we write here is in this the angle in the right triangles is T right here. So we call it opposite, not because it's vertical. It's really because it's facing the opposite, facing the angle T. And adjacent is because this side is actually next to the angle, whereas hypotenuse there is only one. Okay, so basically the hypotenuse and the adjacent side include the angle, whereas the opposite side is facing the angle. If you define, because this is a right triangle, right? If you draw the right triangle in any other way, like say for example you write this being T, then all of a sudden this side that T is facing become the opposite. So there is there's not a definition of the opposite has to be vertical like in a unit circle. Okay, so let's do some drill about writing sine, cosine, and tangent of a right triangle. So if I have an angle alpha, I want to find cosine alpha. How do I find? So you can see that this right triangle has all three sides given. So cosine alpha, let's remember, so ka toa. So cosine will be ka, right? Cosine of that angle alpha is equal to a over h, a over h. So now what is the adjacent of a? Adjacent of alpha will be 15, right? So this is a. And what is the hypotenuse of this triangle is 17. So this is h. So we would write that is equal to 15 over 17, and that's the exact value of cosine alpha. Okay, we call it the exact value. Example 2. For the right triangle below, find the exact value of all six. I don't think we need to. Yeah, 6 trig functions of angle theta. Now here I only give 3 trig functions. Where is the other 3? So it would be the same. So, we would have cosecant t is equal to the reciprocal h over o. Secant t, which is the reciprocal of cosine, equal to h over a, right, reciprocal, and also cotan of a equal to a over o. And in all cases, we don't have to say that O is not 0, so all of them are not 0, so it is all defined. So if that is the case, so what can we say? Let's label all the O and H first. So now H is not given. So the first step we do is actually find out what C is, or maybe we can call it C. By Pythagorean theorem, C squared is equal to 6 squared plus 5 squared, right? C would equal to square root of 36 plus 25. So that would be square root of 61, which is not a any which is already simplified. Simplified the radical. That means you cannot factor out any square number anymore. Right. Oh, it is, yeah. So then we write it as 61 here, and then we are ready to write the 6 definitions. Sine theta, which is here. So this is the opposite. This is the hypotenuse, and this is the adjacent. So sine theta is saw. O over h is 5 over square root of 61. If you want to, you can rationalize it, but we'll leave it the way it is. Cosine theta is equal to ka. Ka is a over h. So a is 6 over square root of 61. Toa, tangent. Toa o over a, right? O over a is 5 over 6. And then the other 3 would be the reciprocal. Reciprocal of sine is cosecant theta, or a, is equal to square root of 61 over 5. Secant theta is square root of 61 over 6. And then cotangent theta is equal to 6 over 5. Just reciprocal it. So this is the exact value, namely the exact value. Okay. When they say exact value, you don't round the square root of 61. Example 3, again, find exact value of all 6 trig functions of angle A. Where is angle A? Well, actually, angle A is here. So in this case, this would be what is opposite to A would be this one. So this become opposite, although it's horizontal, is opposite. And this is adjacent to A. So this become adjacent, and we have the hypotenuse C. We have to find. C is square root of 4 square plus 10 square. So that would be 116, right? 100 plus 16. So 116 is divisible by 4, I believe, right? Divisible by 4 is 29. So it is 4 times 29. So that's 2 root 29. So simplify as the simplest radical. 2 root 29. So we're ready to write sine A saw O over H. So O is 10. H is 2 square root of 29, so we would say 5 over square root of 29. You can rationalize it or just leave it the way. Cosine A would be ka. Ka is A over H. A is 4. So 4 over 2 square root of 29. So that means it's 2 over square root of 29. After you simplify, you need to simplify the outside. Tangent A is TOA. O is 10, A is 4, so it's 5 over 2, right? And then we write the other by doing reciprocal. Cosecant A would be square root of 29 over 5. Secant A, which is the reciprocal of cosine, is square root of 29 over 2. And also cotan A is 2 over 5, just the reciprocal of tangent 2 over 5. And there we have the sixth exact value of the trig function. And then the second part is about special angles. Now, special angles we know is 30 degree, 45 degree, and 60 degree, right? So if we, now 30 and 60s are actually the same triangle. So if we have a special right triangle of 45, 45, we can draw a right triangle like this, where the side is, I think I talk about this in the prerequisite before we do unit circle, is anytime we have a 45, 45 right triangle, if the two sides is any length A, the hypotenuse is A root 2, right? So we can actually write a template. The easy remember one would be 1 root 2. Okay, so this is the one that we would remember if it is 45 degree. And for the 30, 60 degree triangle, you can draw this one. Okay, or we can draw a 30, where 30 degree is in the horizontal. So for that one, if the shortest, we would have the relationship where is A with 3 and 2A. So if I have 1, the hypotenuse would be 2, and the long leg would be 3. Okay, we call the two sides of a right triangle leg. So this is the long leg and this is the short leg. So we have these two relationship 60. And because we have the sine, cosine, tangent defined that way, we can actually just use these two right triangle to generate sine, tangent, cosine, and everything. So I can write sine 45 saw O over H, 1 over root 2, so it means root 2 over 2, right? Cosine 45 is also root 2 over 2 because adjacent over hypotenuse is 1 over root 2 also. And then tangent 45 would be equal to what? Tangent is TOA, so it's 1. So we have these three things. And what about 30 degree? 30 degree, sine 30, saw 1 over 2. So this two triangle, if you can draw it out, it helps you to generate these 9 numbers. That is exact value of sine, cosine, and tangent 30, 45, and 60. So namely 1 root 2, 1 2 root 3. Really easy, actually easier than the unit circle. But if you're comfortable with using the unit circle to find all these values, that's fine. This is just a little easier if you know SOHCAHTOA. So let's continue. Cosine 30 first. Cosine 30 is, if I look at this as the angle, then adjacent would be root 3, so that's root 3 over 2. Tangent 30 would be TOA. TOA is 30 is 1 over root 3. So that means root 3 over 3 after we rationalize it. And then we can continue to do sine 60. Using 60 over here to see saw is root 3 over 2. And then cosine 60, car, so the adjacent is 1. Hypotenuse is 2, so 1/2. Right, so you can see how you can generate all of them. Tangent 60 would be TOA. TOA would be root 3 over 1, that is root 3. So this 9 number is useful for us after you generate all the special angles number without actually referring to the unit circle. Of course, you can do the unit circle also. So say, for example, if I have a right triangle like this, which is a 30-60 triangle, I want to find the missing side. We can use these angles to do. We'll do it in the next video.